Hello folks, welcome to another episode in IB Electronics World. Today we will talk about how we can blink an LED by using a microcontroller PIC24. So last time we said that you can initialize the port by using the trace-A bit. So the trace-A bit, you can select actually the port and set it as an input or output. And by using the LAT, this is a porting latching register, when you can write to the port, for example, turn on the LED by setting 1, or turn off the LED by setting 0. However, there is an easier way after that, because in the future you're going to start long programs and you will not be able to understand what you have add in the pin number 1 or pin number 2, an LED or a motor or something else. So it will be very difficult to distinguish between the lat A and 0 and lat A1 or lat B12 or etc. etc. So in order to do that, we can define a special name for that. Let's try to define by using hashtag define. We can add the name LED in our case, but before we continue with that, let's see, because we didn't test it on the hardware, and today I have prepared the hardware, and in order to show you what we did last time, and when I was explaining that in the infinity loop, if there is no delay, you cannot understand if the LED is turning off. So in that case, it will be all the time on. But let's see what we did. So we are going now to compile it and upload the software into the microcontroller. And I have a second camera, which is going to capture the LED. So in that case, you can see that I have to hooked up an LED on the, if you go on the data sheet, you will see that it's an analog pin, RA0, which is the second one, and in our case it's the second one pin here, which is this one, and I have also a second LED which is embedded on the board. But because it was more visible here, I have hooked up an LED and a resistor in order to protect. So let's start making more clear our software. So you can define the LED here and say that the LED will be underscore lat A0. So this is the quickest way in order to, instead of writing all the word, you can do exactly the same by adding this and leaving like that, but I think it's better to do that in this way. It's quicker and more neat. So by adding again hashtag define tag, you will add the LED trace. This is the name, and again underscore trace A0. Don't forget to specify which bits of the pins, and then instead of using this trace A bits trace A0, you can just say copy the name here, paste it here, and it will be exactly the same thing, and you're going to be able to set the port A 0 pin, that it will be as an output. And instead of doing that, you can say copy the name of the LED and then paste it here, and again paste it here. But there is an alternative way that you can do exactly the same thing by reducing the lines of code, which you can add that symbol here, which means toggle the LED. So that means toggle the LED. So it will. So actually, we don't need that point here, and it will start toggling. So switching on and switching off the LED. But as I said in the last episode that it will do exactly the same, so it will remain as on LED. We need to add some extra delay in order to be able to see the difference between the LED on and LED off. So we're going to create a new function here, which is going to be our delay. Delay void, and then open brackets. So we need to create two variables I and j, and then with for loop, which is going to count a certain point I, and then greater than I, and this is where it's going to end, and it will continue to the next loop, I++, and then another loop for loop, which is going to be j equal to 0, and then j greater than j and it will stop here, and then j++ and semicolon. So now we have two errors here. It's the I end and j end, and it's normal because we haven't defined the values of these two. So again, we can do the same. We can do I end equal to 290 and j end equal to this number, but I prefer to do with define tab, and then I end 290. So practically the 290, the I end is equal to 290, and then define j end equal to 1000, which is the j end is equal to 1000. So now we're going to start until we reach the point 290, and then we're going to continue with the second for loop, which is going to be 1000. And after the LED, we need to call that function, and in order to call, we need to write the word, open parentheses and semicolon, and that's all. So with that delay, it will be approximately 100 milliseconds. It depends. Again, it depends on the oscillator mode, what we have selected. But at this moment, we haven't selected anything at all. If it's going to be FRC, so this means that it will run to 7.37 megahertz, and so on and so on. So in that case, we will see what it does. The hardware I have also hooked up an oscilloscope as well. So actually have an error. Yes, so the error is trees. I forgot. Yeah, this is very important. So if you have a typo, it will have an error, and the compiler will catch this up, and it won't allow you to compile the project and upload it also into the microcontroller. So with the oscilloscope. With the oscilloscope, you can see that in 1 cycle, while we run one time the while loop, it will be 633 milliseconds, and it's 6 times greater than the 100 milliseconds that we were expected. In order to do that, we need to configure actually the microcontroller by adding some configuration command, which is the pragma, and then config. We want to configure the oscilloscope, the oscillator, sorry, equal to FRC PLL. I will explain later on what are these configurations in my next episode. And so practically we are setting the oscillator mode to the internal oscillator. We don't have any external crystal, and we are setting to the fast RC with PLL. So if we are going to compile now again our program, so we are going to see the first thing that we are going to notice. So actually sometimes the software doesn't run, so we need to unplug the device and plug again the device, otherwise it will never start. And then you need to click again on upload the software. While uploading the software, you will see. So now the LED has started blinking faster. Let's see in the oscilloscope. So in the oscilloscope, we'll see that the time has dramatically reduced, and it's now 100 milliseconds. And as you can see, the LED has started blinking. So that was it for this episode. Thank you for watching. I hope you enjoyed. Please, if you enjoyed, click on subscribe, and please add some comments if you would like to recommend some extra videos. Thank you very much for watching. See you in the next episode.